Hello everyone, thank you for attending this session. I'm Christian Wade. I'm excited to be here presenting at SQL Bits. I've never presented at SQL Bits. I've presented at the past Community Summit a few times. I flew in from California yesterday, because I've been living there for 7 years, didn't get much sleep. I don't know whether I'm going to overdose on melatonin or Red Bull right now. So if I start talking really fast and then suddenly look as though I'm going to fall asleep, then you know why. Let's see. I've got my own little consulting company out there in California. I'm an independent consultant. I'm also the creator of the BISM Normalizer tool, which is a free tool developed for the SQL community, which I'll show you in a minute. I actually changed the session abstract a couple of weeks ago, and depending on whether you're looking at the printed version or the guidebook version, even if you're looking at the old version, we're still going to cover everything in the previous session abstract. But in addition, we're going to also cover the benefits of database compare for analysis services tabular models, and we'll look at this tool that I built called BISM Normalizer. This is easily the best thing that I have to offer you, and it's something you're not going to see in another session. So I thought I'd spend the first 15 minutes or so on that. Then we'll move on to currency conversion. Everything I cover for currency conversion is reusable in other scenarios. It's all stuff you want in your toolbox. So we'll start off with the relational model. We'll then look at the multidimensional and tabular models that sit on top of it, and then we'll start querying them with MDX and DAX, and we'll compare and contrast the languages and see how we're basically achieving the same end result in very different ways. All right. So this tool, the BISM Normalizer, I built this in my spare time as a hobby, and it's a database compare tool for analysis services tabular models. It only works on tabular models. There is nothing else out there that does database compare for tabular models, and as I said, it's a free tool that you can get from the Visual Studio gallery. Now, database compare for relational databases is a mature area. There are products like Schema Compare, which comes with Visual Studio or SQL Server Data Tools for a few pence extra in Visual Studio Premium or Ultimate. And actually, the user experience of BISM Normalizer is very similar to Schema Compare. And then there are probably another 10 products out there that do database compare for relational databases, including Redgate's SQL Compare. So why do we need, or what are the benefits of database compare for tabular models? Firstly, it allows us to reuse definitions between tabular models. You know, my primary customer for 7 years is a global oil company with business units throughout the world. And in an enterprise organization like that, it's inevitable that there will be multiple implementations, multiple data warehouses, cubes, tabular models. It's also inevitable that there will be a fairly considerable overlap in terms of the business definitions covered by those models. Couple that with the fact that we're at the eve of the next generation of BI, the in-memory analytics database or database revolution, whatever you want to call it. So in 5-10 years' time, there will be tabular models all over the place. How do we try and get a grip and try and manage these models with a considerable overlap in an enterprise organization? So BISM Normalizer can certainly fill that gap. We can also use it to help bridge the gap between self-service BI and corporate BI, because we can use it for migration from Power Pivot to analysis services. So I think everyone here knows you can get a Power Pivot model into analysis services using import from Power Pivot, but what then? We're kind of stuck at that point, right? Are we supposed to have a separate analysis services database for each Power Pivot migration? Like, what we really want to do is take the Power Pivot migrated model and merge it into the relevant corporate BI model. We can use it for that. We can use it for branching a code base for parallel development, which is a notoriously challenging thing to do maybe in the app dev world when you come to merge the changes after. Right? And you know, they're typically dealing with C# files. For us, with the XMLA behind the BIM file, it's practically impossible without a tool like BISM Normalizer. Another variation of that use case is that you can only have one developer on a project at a time because there's one BIM file for the whole project. with BISM Normalizer, have multiple developers work in parallel and merge the changes when they're done. And then deployment, let's just talk about deployment of tabular models for a minute. When we deploy our tabular models, it's nice to not have to reprocess all the tables in the tabular model. Just like when we deploy a new version of the data warehouse, we might use DAC packs or schema compare or DDL scripts to bring the version of the data warehouse up to the latest version without dropping and recreating the database and reloading all the data. Right? Same deal with tabular models. And which are the tables in the tabular model that we really don't want to have to reprocess? The big ones, the partitioned ones. That, you know, that's the only justification for partitioning in tabular, is to speed up processing times, right? So, and the thing is that the partition objects are almost always created and managed by the ETL. So we might have a sys package that calls a script task that then implements, that calls some AMO code, for example, that then implements a rolling window pattern or something like that. But the point is that because the partition objects are created and managed by the ETL, they don't exist in the version of the tabular model in source control. So if we do a right-click deploy from Visual Studio, the partitions are toast, right? So we need a way of deploying the tabular models that supports this retain partitions functionality. And there are only two ways of doing it for tabular models, which is either BISM Normalizer and the Analysis Services Deployment Wizard that support this retain partitions functionality. So let's just see how they stack up for a minute. For a regular release to test or production, I'm not trying to compete with the deployment wizard there. There are some extra features in the deployment wizard. You can run it from a command line. You can have it integrated into a TFS build. Now, you know, I don't want to sound facetious, but I strongly suspect that there are a lot of projects out there that haven't gone to the trouble of setting up the deployment wizard with a TFS build that could benefit from an easy way of generating an XMLA script, handing it over to a DBA, associating it with a release, having it applied to test and production in such a way that retains partitions. But let's not even go there. Let's just say we live in utopia and everyone has set it up fully correctly, right? So therefore, there's no real benefit for a standard release to test and production in terms of the ease of use value. All right. However, even if we are using the deployment wizard, there's still a bunch of use cases where we need to deploy the tabular models and we still want to retain partitions, and the deployment wizard is overkill. So for example, during the development process, I'm developing away on my laptop. I've got my little workspace database, which is pretty much redundant in an enterprise development scenario. It's basically a hangover from Power Pivot. I happen to not have 50 gigabytes of memory on my laptop. I'm quite bitter about that, but that's the reality. And plus all of my reports, maybe on my SharePoint portal, they're not pointing at my workspace database, they're pointing at the development instance of the tabular model. Now while I'm developing, I need to deploy to dev practically every 5 minutes, right? Every time I make a change to a DAX measure, add a little table, whatever, I need to deploy to dev. And I want to do that from Visual Studio. It's overkill to use the deployment wizard in that scenario. So BISM Normalizer can fill that gap. And actually, this is the same use case pretty much the way I see it. If you know BIDS helpers deploy MDX script, but obviously that's for multi-dimensional and BISM Normalizer is for tabular. So with BIDS helpers deploy MDX script, you make a change to an MDX calculation, you want to deploy to dev, and you still want you want to retain partitions on dev as well, because you want dev to match up with test and production. You want to make sure that your partitioning code is running in dev. Right, so it's the same type of use case as deploying MDX scripts with BIDS helper, and that's definitely a big gap that the deployment wizard doesn't fill. And then another potential or another pretty good use case is hotfixes. Let's say we've got a DAX measure out there that is causing major issues. It's doing a gross miscalculation or something out there on production. Customer is unhappy about it. We want to get a new version of this DAX measure out there as quickly as possible. Doing a full release cycle isn't necessarily what I want to do. And B, the deployment wizard isn't the best tool for the job there anyway, because it's an all or nothing committal. I just want to script out that single little measure, hand the script over to a DBA, have it applied to test and production in such a way that doesn't mess with everything else that's out there, right? And that's why the deployment wizard doesn't fill that gap either, right? So even if we are in the situation where everyone's gone to the trouble of setting up the deployment wizard and the TFS build, etc., there are still a bunch of gaps that that BISM Normalizer can fill. You know, I think probably in 5-10 years' time, the deployment story for analysis services will probably look more like the deployment story for relational databases with DAC packs and schema compare and things like that. In the meantime, you can use BISM Normalizer to fill those gaps. All right, I'll give you a quick demo of it. So I'm going to reuse a couple of objects like these currency tables from one model to another. So I'm going to take them from this tabular model and put them in this corporate model. So I get this compare tabular models toolbar button. If I click on that, and one thing I'm going to call out here is that there are a few options here that I'm not going to talk about, but this include partitions in table definitions. You would want to leave that unchecked in order to have that retain partitions functionality that I was talking about, because otherwise it's going to actually compare the partition objects as well. Right? So at this point, the source and the target can either be a project or a database, just like schema compare. And if you're deploying to dev, you would specify the dev database here. But in this case, I'm going to leave it as projects. It'll go ahead and list all the differences. And let's see. And it supports all of the tabular model objects that the tabular model designer in Visual Studio and Power Pivot supports: tables, relationships, measures, KPIs, connections, partitions, roles, perspectives, everything. So we want to push these currency objects through to the target. And in a situation where we're reusing some objects from one model to another, and the target might be a mature model, it might be a mature corporate model, there's quite often going to be a load of stuff in there we don't want to mess with, right? There could be hundreds of objects in there we really don't want to mess with. We just want to reuse a couple of objects. So for these objects that are saying missing in source with a delete action item, rather than coming in and skipping them all individually, we can say skip all objects missing in source, and with 2 clicks those delete items get skipped. Right? Then we've got internet sales here with different definitions, because the target is missing the ship date key column, and it's called that out. We'll leave that one. And then for whatever reason, these other objects, we don't want to push those through, so we'll skip all of those. And then just like schema compare, we can say hide skip objects, and we can focus on the differences. Then we go ahead and validate the selection. At this point, it's going to tell us what it's going to do, and it's going to give us any warnings for name conflicts and things like that. The validation is pretty thorough. It's not like a lot of the relational database compare tools that will give you a warning and still try and apply that change and potentially give you an error when you try and apply it. It's going to say, I'm not going to create a measure with the same name because I already know that the target has got one with that name, and it won't even try and create it, right? But it will tell you that it's not going to create it, right? And if you, yeah, so, and then at this point, we can report the differences to an Excel report, which is useful for alignment with common business definitions in an enterprise organization. We can script the changes if it was a hot fix, or if we're using it for, as an easy way. As you saw, it's very easy to run this as an easy way of generating a different script, like an XMLA script. Although again, we're not challenging the deployment wizard for a standard release to test and production, but you can certainly script it out. Or you can just commit the changes to the target, which is what we'll go ahead and do. Refresh the comparison, and we should see that the currency objects are now in the source and the target. And internet sales has now got the same definition because the ship date key has been brought through, and everything else that we skipped is still listed as a difference. And if we open up the corporate model, we should see that those objects have been brought through. So there's the currency rate tables, and then switch to diagram view, we'll see them there as well. So that's BISM Normalizer, very easy to use, hopefully fills some gaps in there that you can use as analysis services developers. Let's move on to currency conversion. Just leave that open in. All right. Any questions about BISM Normalizer, comments or anything? I'll just move on to currency conversion. Okie doke. All All right, so I'm going to basically skim over this slide. I'm just going to say that I'm going to be using one-to-many currency conversion in my demo, which is the most common form in the traditional data warehouse type situation, where we store all our transactions in a single base currency. I'm going to be using a subset of adventure work, so my base currency is going to be US dollars. I've been living in America for 7 years. So we store them in the single base currency in the fact table or the data warehouse or whatever your data service layer is. And then we use the cube or the tabular model to convert to the reporting currencies. So the basic business requirement is that the users can see all of the transactions in any of the supported currencies. Now, we store them in the base currency, even if they actually originally took place in different countries, in different currencies, and even if the system of record that we're pulling the data from actually stores those original values in different currency values. We then use the ETL to convert to the base currency, and then the cube or the tabular model converts to the reporting currency. So there are two passes of the conversion that typically needs to happen. The first one's done in the ETL, the second one is done in the cube or the tabular model. So this kind of asks the question, which can be a bit of a controversial question, when should we do calculations in our ETL, or when should we do our calculations in the cube or the tabular model? And I'm going to answer it from the kind of traditional perspective. I'm not really going to factor in self-service BI or organizational capability. You know, there are people out there that, a lot of people that just hate MDX and DAX, and a lot of other people that absolutely love MDX and DAX, kind of like Marmite. So I'm not going to factor in any of that, like organizational capability or anything. So there are calculations which are much better suited to the cube or the tabular model. Traditionally, those are aggregated level calculations, certainly for multidimensional. Multidimensional is great at the aggregated level. Tabular is great at the aggregated and at the detail level in many cases, but the ETL is just not good at the aggregated level, right? So we can say already that aggregated level calculations are a prime candidate to be done in the cube or the tabular model. Or there are a lot of calculations that would cause a data explosion problem if we try and do them in the ETL, or could add complexity to the model. So that second pass of the conversion from the base currency to the reporting currency, if we try to pre-calculate all of those values in the ETL in a relational model, technically we could do that, but we would explode the fact table size by the number of reporting currencies that we need to support. So that's not a good, so that's like a data explosion problem. Again, there are lots of other data explosion problems that can happen if you try and push those calculations down to the ETL. However, if your calculation doesn't fit into those categories, which are the strengths of the cube or the tabular model, then call me a traditionalist, but I like to push them down to as low as you can, potentially the ETL or whatever you'll use as an ETL under your service layer, because then it means those calculations are more reusable, right? So there might be consumers of your system that you need to support SQL queries. They may not necessarily be going through the cube or the tabular model, so push them down to the ETL, and use the ETL for what it's good for, right? I mean, and I've seen a lot of multidimensional cubes out there that have performance issues because they're trying to bite off more than they can chew, and they're trying to do calculations that probably would have been better done in the ETL. Tabular is quite forgiving in terms of performance, but still, the more calculations you do, the more time you're going to spend in the formula engine, the less you're going to bypass it and go straight to the storage engine, which for tabular is where VertiPack and XVelocity reside. So, just use the tools you've got available across the full architectural stack to end up with a more efficient solution, all right, that promotes reuse of business logic as well. The lower you put the business logic, the more reusable it is. Okay. I said I was going to skim over that slide. I probably spent 5-10 minutes on it, but I've had 7 Red Bulls. So anyway, and about 11 melatonin. So I might fall asleep at any minute as well. No, I'm just kidding. All right. So this is our model. So we store our transactions in our single base currency. Let's say US dollars. Each transaction is associated with a date. If we have a currency or an exchange rate data set that goes down to, say, minute granularity, then we'd probably want a time dimension hanging off there as well. And then we would actually pick the exchange rate that was in effect at the time that each individual transaction took place, and we'd have a more accurate currency conversion, because obviously the exchange rates are going to fluctuate even over the course of a day. Most of the time we're not going to have an exchange rate data set that goes down to that level. We'll just have like AdventureWorks and an end of day rate or something. So therefore, for each day, and we're storing our exchange rates in this currency rate table. So for each date, there are going to be many currency rate records, one for each of the supported reporting currencies. And similarly, for each currency, there are going to be many currency rate records, one for each of the dates in the date range that we're loading data, because the exchange rates are going to change over time. So the correct way to model it is with a many-to-many relationship between date and currency, and therefore currency is a many-to-many dimension with respect to sales. And here's some grossly simplified data. This is my base currency, right? In this case, you'll have to forgive me, the foreign currency is British pounds. Obviously, these are not the correct numbers that we would want to see. Why am I showing this? I'm showing this for two reasons. Firstly, this is the default behavior of many-to-many dimensions in multi-dimensional when we set up the many-to-many dimension. As long as there's data in the intermediate table, it will just show the same value. And there are many valid business scenarios where that is what we want. So like the account balance scenario, we've got a bank account and we've got multiple account holders. We're going to show the same balance for each account holder, right? And so there are many valid business scenarios for this, but not in the case of currency conversion. Having set that up, we then want to apply the conversion, which we get from the currency rate table. And one thing that's not illustrated by this little table here is that we want to apply it at the leaf level, at the lowest level of granularity. Like I mentioned earlier, we want to pick the exchange rate that was available for each day that the transaction took place. We don't want to do it at the month level, which is what it appears that we're doing here, right? Okay, and another interesting little requirement is that if we can get away with it, we'd like to not even have an all member. So, as I'm sure everyone in the room probably knows, you drag a hierarchy onto a pivot table, you've got the all member, which is normally the sum of all the children. It doesn't make sense to sum up different currencies. So if we can get rid of the all member, we'll get rid of it. If we can't, then we have to show something more applicable, more appropriate. We could show not applicable, but that wouldn't be the best thing to do because it would explode the cube space, and more importantly, the users, can be doing ad hoc analysis. They might be looking at sales not in the context of currency. They might be looking at sales in the context of customer and product or whatever. And then what are they going to be looking at by default? Well, if we had NA as the showing for the all member, which is the default member, then they'd be looking at NA, which is not appropriate. So we might want to show the base currency if we can't get rid of the all member, right? Okay. And then the whole rest of this session is going to be a demo. We've got plenty of time. All right. Let's start off with the multidimensional model. So here's the DSV, and this is just a subset of AdventureWorks. As you can see, the relationships are the same as that model we saw in the slide. Obviously, we're only using one of these relationships. Here's the currency dimension. Go to the properties, and there's a couple of properties I want to call out here. So this is aggregatable equals false. That's going to get rid of the all member, which we just said we want to do. And multidimensional is such a rich modeling experience. There's a load of bells and whistles. This is one of them. We can get rid of the all member. But if we get rid of the all member, normally the all member is, well, by default, it's the default member. So we need to specify another default member. That probably doesn't make any sense the way I just said it. But what that means is that if the users haven't applied a filter on currency, what are they going to be looking at? Well, normally, the all member would be the current member, so we need to specify a different default member. And then here we're specifying US dollars. That's the unique member name for US dollars, which is set using the key column property here, and the users would see the name column property value, and that's just how we set things up in multidimensional. All right. And I'd also like to show you, this is the cube, and to set up the many-to-many dimension relationship couldn't be easier in multidimensional. Literally, probably a couple of clicks, and you've set that up. So now we've got a relationship between internet sales and currency. And the last thing I'm going to show you here I appreciate there's a few people in the room that probably know this, but I'll try and get through it as quick as I can. So this end of day rate has a last non-empty aggregate function, which is one of the semi-additive measures. So everything from average of children downwards is a semi-additive measure. So the classic example of a semi-additive measure is inventory. It's additive with respect to every dimension in the cube except one, right? So if you wanted to show a report with the last 5 weeks, the value of inventory isn't the sum of Monday plus Tuesday plus Wednesday and so on. It's just going to be the last available value that you have for a week. However, if you want to show inventory for all of the cities in the UK, and there's a load of warehouses in each city, you're just going to take the sum of inventory for all of the warehouses in a city. You're not going to sort the warehouses alphabetically and pick the last one, which would be the equivalent, right? So it's additive with respect to every dimension in the cube except one, which is the date dimension. And now let's look at the tabular equivalent. So first little thing I'm going to call out here is I've got 500 million records on both the demos, multidimensional and tabular. It's really not going to make much difference for the demos in terms of performance or anything. You know, that's because the models are so simple. There's such little dimensionality. There's so few tables that it's not really going to make any difference. The reason I'm calling it out is that the numbers you're going to see are going to be like $20 billion or 15 billion pounds, which is obviously not what you normally get in AdventureWorks. Why did I put 500 million records in there? For fun. And then over here I've got, so as you can see, there's over $250 billion worth of internet sales. All right. Then the model itself, I mean, there's a few little bells and whistles there. Like, you know, there's a few properties here and there, but it's nowhere near the rich modeling experience that we get with Tabular. There's nowhere to specify is aggregatable or default member or the many-to-many dimension or the semi-additive measure. All of that is offloaded to DAX. So DAX assumes a lot more responsibility, right? So, you know, as you can see, it's just a bunch of tables, columns, and relationships. All right, let's start querying them. So here is an MDX query against the multi-dimensional model. And this is showing me all of the periods in 2006. And as you can see, I just specified end of day rate, and it just works. So January 2000, for January I've got 1.51, which is the same value as January 31st. I didn't have to do any special calculation for that. Similarly, for the whole of 2006, 1.42, which is the same value as December 31st, right? And the exchange rate to get from US dollars to British pounds is about 1.5. Which is, and I've got a slicer in the where clause, and this is the unique member name for British pounds. So you may ask, well, what would happen if we ran the query without that filter or slicer? We'd get back a load of ones. So why is that? Well, that's because if we look at the currency hierarchy, and this is the same as what the users would see in a pivot table, first off, we got rid of that all member, so that's not visible there, so that was a good thing. And then we had to specify the default member, which we specified US dollars, which is why if we don't put a filter, the current member is US dollars, and that's why we're seeing a load of ones, because generally, you know, if you've got US dollars and you want to convert US dollars to US dollars and your formula is to divide by the exchange rate, you can divide by 1 and generally you'll get the same number. All right. Now, let's try the same thing on the tabular model. So for the tabular model, we could obviously use MDX or DAX. Now, if we were to use MDX, would it be the same MDX query? No. For a start, the unique member name would be different. We don't get to specify the key column and name column properties in tabular. And the big difference would be that we would have to calculate the end of day rate in the query if we haven't already built it into the tabular model using a DAX measure. But the point is we have to calculate the end of day rate. So if we were doing it in MDX, we could use descendants of the calendar current member, get a set of all the dates and pick the last one, maybe using the tail function. But we're not going to use MDX on the tabular model. We're going to use DAX instead, just because we're interested in it and we want to learn about it. So this is the DAX query, which, as you can see, is a lot more complex. But that's not because DAX is a more complex language. It's because it has to do a lot more work. It has to calculate the end of day rate. So let's run that. So here we've got the days in January and the month of January, 1.51, and that's the same value as January 31st. And by the way, exchange rates is actually not a classic example of a semi-additive measure. You know, it's probably, you could argue it's not additive with respect to any dimension, but it's just the way that AdventureWorks did it, and I'm not going to argue. If AdventureWorks did it that way, it must be right. So rather than using the calendar user hierarchy, we're using this roll-up function because it's not aware of user hierarchies. So that's what gives us the January value. And then for the calculation, for the last non-empty calculation, I've broken out the calculation into components, into 3 separate measures. We would only actually expose the last one to the users. And that's just a best practice for debugging and readability. So the first thing we do is sum end of day rate, which doesn't make any sense. Then we're using the shorthand notation of the calculate function to apply this last non-blank function as a filter to the calculate function. So this would have been exactly the same as saying calculate, open bracket, comma, and put in your calculate function parameters. So instead of doing it that way, we're just going to list an existing measure, open bracket, put in your calculate function filter parameters, and it works exactly the same. So I'm sure everyone's heard of the calculate function. It's the most powerful function in DAX. It allows you to override the filter context, and you know, I'm sure you've heard of filter context as well. It's not the type of thing I think that everyone gets immediately first time. You know, the MDX equivalent of filter context is the current dimensionality of a cell determined by the current member of every hierarchy in the cube, kind of like the current coordinates of a cell. For tabular, we have filter context instead, which is all of the rows currently being filtered on for all of the tables in the model, which is admittedly a lot more relational-like, but it's still not something you're going to get immediately. I think you'd get it more easily if you know a bit of MDX, to be honest. So here we're going to override the filter context and create a new one using this last non-blank function. Now, the last non-blank is going to pick the last non-blank row from the date table, and it's going to be evaluated for each of these cells. So, for example, when we evaluate it for January 3rd, there is only one date row in filter context anyway, so it's not going to actually make any difference. However, when we evaluate it for this January cell, there are 31 date rows in filter context. Last non-blank is going to pick the last non-blank one, which is January 31st, create a new filter context filtered by January 31st, which is why we get the same number. Okay? All right. Let's switch back to MDX. And here I've got internet sales by year on columns and currency on rows. At first it looks like we've got the same value for every currency. We haven't quite got the same value for every currency. We've got these nulls here for Deutschmarks and French francs. And the reason for that is that the exchange rate data set in AdventureWorks is incomplete with respect to Deutschmarks and French francs. And actually, if we comment out this non-empty, we'll see that there are actually a load of other currencies in AdventureWorks which don't have any exchange rates populated at all. Right? In fact, there are 106 currencies and only 15 of them have any exchange rates populated. And again, therefore, that's proving that it's only showing, this is the default starting point for many-to-many dimensions in multidimensional, and it's proven that it's only showing the values if there is data in the intermediate table, right? Okay, let's try something similar from DAX on the tabular model. This isn't actually the result set we want, but we may try this at first. So we're simply taking internet sales and reporting it by each of the currencies. And the difference here is that it's showing the values for all of the 106 currencies, whether there's data in the intermediate table or not. So what's going on there? This smells suspiciously like ignore unrelated dimensions from multidimensional. In fact, technically this is ignore unrelated dimensions inherited from multidimensional, because the way that Microsoft delivered tabular was they they leveraged the existing code base that first produced Analysis Services 2005. It was then enhanced. We got block computation in 2008. Then it went through this kind of mutation where it was hosted in Excel as Power Pivot, and then it went through another mutation and it emerged as the corporate BI offering of Tabular. So there is a lot of common lineage, and Tabular has therefore inherited a lot of stuff for free, right? So why did Microsoft do that? I guess firstly to accelerate the delivery of Tabular, but also they did it because it, as I said, it inherits a lot of stuff for free. The most notable bit of functionality it's inherited from multidimensional is support for MDX, right? That alone justifies Microsoft's decision to do it that way. But another less notable bit of functionality that it's inherited from multidimensional is this ignore unrelated dimensions behavior. So if we just take a moment to talk about that. Here we have, this is back in multidimensional. We've got ignore unrelated dimensions, which defaults to true. And that means that with respect to that measure group, if it didn't have a relationship to a dimension, so for example, if this box here was grayed out and it didn't have a relationship, it would say, sorry, if you tried to query internet sales by currency, it would say, sorry, it doesn't make any sense, there's no relationship to currency, so I'm just going to ignore you and I'm going to show you the same value for every currency. Or if you said it, ignore unrelated dimensions equals false, it would just show a null, which in some cases is more intuitive for the users, right? And then, but that doesn't exist in Tabular. Well, technically it exists, if you were to program your Tabular model using AMO, not that I would recommend that you go and set ignore unrelated dimensions using AMO, but it is there in the model. AMO is what I use to build BISM Normalizer. If you're using AMO on a Tabular model, you pretty quickly realize that if they'd rebuilt Tabular from the ground up, you'd be programming in tables and columns and relationships instead of measure groups and hierarchies and attributes and dimensions. So it's there, but I wouldn't recommend you go and set it using AMO. But then you might say, well, hold on a minute. Why is it unrelated in the first place, right? Because if you have a look at the Tabular model, and here's the relationships, we're trying to report internet sales to currency over here. Internet sales relates to date, and it relates to currency rate, and it relates to currency. So what's the problem? Well, the problem is that these relationships here in the Tabular model designer are just simple relationships, and they only propagate to the one side of a one-to-many relationship. So it's going to propagate to date, which is why we saw the year numbers were different. It's going to propagate to product subcategory, and product category, because category is on the one side of a one-to-many relationship to subcategory, which is on the one side of a one-to-many relationship to product. I'm not going to say that again, you get the idea. Whereas when it gets to when it gets to date, it stops there and it says, I'm not going to go to currency rate because that's on the many side of a one-to-many relationship. I wouldn't know which currency rate record you want to aggregate to, and therefore I'm going to consider it unrelated, and I'm just going to give you that ignore unrelated dimensions behavior. But what if we want that data set that we saw in multidimensional, because as I said, there are valid business scenarios where we would want that, like the account balance scenario. And for that, I've got this query, and this is the same data set. So here we're again using the shorthand notation for the calculate function, and we're using the summarize function to create a new filter context where it filters internet sales for which there are records in the currency rate table that relate to the current currency in filter context. A bit of a mouthful, but kind of difficult to understand, but it works and it's a repeatable pattern. Then I think it was Gerhard Bruckel, I've probably mispronounced his name, but he did a blog post and said that actually you can use cross-table filtering. It's a simpler syntax, and it gives you the same result. And the syntax is simpler. And I think then Marco Russo did, and then I think you ran you had a look at the query plans for the two alternatives, and you found that that they were different but kind of comparative in terms of performance. Is that correct? Yeah. Yep. Okay. So it sounds like they're comparative in terms of performance. Therefore, you could choose either. I guess the reason to choose the cross-table filtering approach is that the syntax is simpler. Whereas you might want to use summarize, since that's the only official line I've heard from Microsoft at the past Community Summit in 2011. They said, we should use summarize in this situation. So either seems to be fine, but just thought I'd point that out. All right, back to MDX. So that's all well and good, but obviously we need to apply the conversion. So there are about 4 different ways we can apply the conversion in multidimensional. We can do it in the MDX query, which is what I'm doing here, which is probably the worst way to do it. We can do it in an MDX script cell assignment or in a calculated member in the cube. Those ones are going to benefit from caching in multidimensional, but they're still going to be run at runtime, at least the first time that the user queries the multidimensional cube. Or we can use measure expressions, which we're going to cover in a minute. So what we're doing here is, this is the US dollar amount, 2.7 billion, obviously not what you'd normally see. This is the US dollar amount with respect to each of, that's the original base currency amount. And then this is the end of day rate for British pounds, and then this is the converted value. Now, we did not just simply take this number and divide it by that to come up with 1.8 billion. If we had done that, we would have, the number would have been different. It would have been about 1.7 billion, and we would have shortchanged ourselves out of 100 million pounds. So rather than do it that way, as I mentioned earlier, we need to go down to the leaf level using the descendants function, apply the conversion at that level, and then sum up the results, and then we get the correct numbers. How do we do that in DAX? We can use this sum x. Anytime you see the x, it's like an iterator function. It's going to effectively create its own private row context within the rows that it's inherited from filter context. So for the table that we specify, so it's going to for each of the currency rate rows that it's inherited from filter context, it's going to iterate them all, apply the conversion at that level, and sum up the results. And then if we find British pounds, 1.8 billion, which is the correct number. And when we actually apply this conversion, we need the sum function here with respect to internet sales amount, because if you think about the model, there will be just one date in filter context, but then internet sales is a child of date. So there could be multiple internet sales transactions, but for this one over here, we don't need the sum function here for the end of day rate, because we're iterating currency rate, and there's guaranteed to only be one currency rate row in context. So therefore, we could have used values here instead. Oops. And that's going to return the same numbers, 1.8 billion, wherever it is. So I'm not sure there are any real advantages other than making your DAX look more elegant. But the values function is another one of those DAX functions you really want to know how it works, right? So it's a table-valued function. It's going to return a table with one column and none, one, or many rows. Now, in the case where it's guaranteed to only have one row, as is the case here, then DAX will effectively do an implicit conversion to a scalar value that we can use as an input to another calculation or another DAX function. Whereas if there were multiple rows, it would break here. So that's worth knowing. And we use that a lot. It's just a pattern we use a lot in DAX. All right, back to MDX. So I'm happy now that the numbers are aggregating correctly, that we're looking at the correct numbers. Problem we've got at the moment is that the currency symbols are all US dollars. So we want to change the currency symbols to the correct currency symbol. And for that, I've got another cube, measure expressions cube. And this one has the correct currency symbols. And the other thing you'll notice about this query, I didn't actually do the conversion. I didn't use descendants and sum to do the conversion in the MDX query. I just specified internet sales amount, and it magically works. So how did I do that? Well, again, it's this recurring theme of decorating the metadata of the model in multidimensional. So if I show you, this is the measure expressions cube. So if I zoom in here, you can just about see it. It's kind of difficult to see since Visual Studio has gone for this all black and white theme. I think I don't know if it was in the beta, it was like the all black theme. you can barely see that now, but that's got a little function symbol on it, and that means it's got a measure expression defined on it. And if we go over here, we can see this measure expression, which is just a simple arithmetic operator. It's not full-blown MDX, but the things to know about measure expressions are, thank you, Steph. Firstly, it's calculated at the leaf level, which is exactly what we want for currency conversion. And secondly, it does a lot of the work during cube processing time, right? So for big data sets, we can see a performance improvement by using measure expressions over doing it in any of the other three options which I mentioned, which was calculated member in the cube, MDX script cell assignment, or in the query. Which is why measure expressions is the recommended approach for currency conversion in multidimensional. We also had the currency symbols. I think for the interest of time, I'm not going to show you how I did the currency symbols, but it's all on my blog, so you can check my blog. For tabular, I have got a query that shows the currency symbols. So they're the correct currency symbols. So what I did was I added a couple of extra columns to the currency dimension. We've got this LCID, which is the Microsoft Locale ID, which is what's used by multidimensional, using an MDX script cell assignment, using the value column property. The details are on my blog. Then I've got this format string column, which is used by tabular. So for tabular, we can just specify. We're doing the calculation the same way we were before. There's obviously no measure expressions or anything for tabular. So there's only one recommended way to do that, and that's with SUMX. But for the currency symbols, we're just using the format function and just picking out the format string from the currency table, and everything works fine. Now, the thing is that it needs to have one currency in filter context for this to work. If you remember, I said the values function is a table valued function. If it's guaranteed to only return a single row, it will effectively do an implicit conversion to a scalar value that we can pass into another DAX function, which is what we're doing here. Now, are we guaranteed to have only a single row? We are, because of the next measure. You know, this is why we would not expose this measure directly to the users. So for example, if before I move on to this measure, if you look down here at the columns, in the column definition itself, I'm using the shorthand notation for the calculate function, where I'm filtering by particular currencies, right? So in the case where I'm filtering by those currencies, I could have actually used this measure and it would have worked, because we would have only one currency in filter context. If I run that, whoops, everything works. However, this last measure down here, this doesn't have any filters on the currency table. Therefore, if we try to replace this one with that measure that uses the values function, if we use that, then we're going to have a problem. And it's going to say a table was supplied where a single value was expected, because the measure was evaluated and we had 106 currencies in filter context. We didn't filter by any currency, right? So it had a problem and it said, sorry, I don't know what to do and I'm going to give you an error. So what we do instead is put this other wrapper measure around it. Again, it's a best practice in DAX to break your calculations out into separate measures. So put this other wrapper measure around it, which is the one that works, right? Now everything works. But what happened there? Well, when this measure was evaluated for this column down here, it's going to do a check on, it's going to use the has1value function to check whether there is just one currency in filter context. If there is, then we can just use that previous measure with no issues. But if there are multiple values in filter context, then we've got a problem. We can't sum values of different currencies, so we have to pick one. Right? So we're going to force it to be the base currency, which is US dollars. And this is the kind of workaround, or one of the workarounds that you can do to not having the default member property. You know, this is the kind of DAX workaround to not having the default member. So if we look at the currency hierarchy, we couldn't get rid of the all member, which we did for multidimensional, right? There is no is aggregatable property, at least that you can set in the tabular model designer. so we left the all member, but then what if the users haven't specified a filter on currency? What are they going to be looking at? Well, they're going to be looking at US dollars because we use the has one value here and force it to be US dollars if there are multiple currencies in filter context. And this also overcomes the case where someone's put in a multi-value filter on currency, which again doesn't make any sense. All right, so this is our kind of workaround to the default member. And I think that's pretty much it. I think I've pretty much run out of material, and I've still got 10 minutes left. But that's about it. Any questions? I was kind of allowing a bit of time for questions. Any questions from it? Yeah, go ahead.
I'm wondering if your tool can compare cubes in different servers, or do you require tabular model?
It only works for tabular models. To be honest, the very first version, I did have a version that worked on multidimensional, but the only person I was comfortable releasing that to and allowing them to use it was me. Because there are so many dependencies in multidimensional. Tabular is much cleaner, right? The code behind it is just as much of in terms of AMO, is just as much of a mess as multidimensional, but it's much cleaner. There's just tables, columns, and relationships. The validation that I had to do on the multidimensional version went off the chart, and I wasn't even confident that I had all the cases covered, right? So I think Redgate, they created they had the SAS compare tool. They were trying it on multidimensional. I'm not, I don't know why I'm assuming that they're not moving forward with that since they're now giving it away. I don't know. I don't want to put any words into Redgate's mouth, but I'm assuming they had similar types of issues, right? And so that validation piece for tabular is much cleaner, but for multidimensional, it was just too much. But it did give me a head start to be able to I had BISM Normalizer released before SQL 2012 hit RTM, right? I actually had it released in December 2011, right? Way before RTM, because I had a head start on it because I'd been working on the multidimensional version, and then I just made a few changes here and there and released it as the tabular version. All right. Any other questions? Yep.
Could you have done most of the DAX calculation stuff in the model as well?
Yes, absolutely. So thank you for mentioning that. I forgot to mention that these measure definitions, the measure body is exactly the same syntax as if we built it into the tabular model itself, potentially using the formula bar here. So certainly the measure definitions could have been built into the tabular model for sure, and we would want to do that. So I was doing it in the DAX query just to show us DAX queries, but you're absolutely right that we would want to do that.
Has one value.
Absolutely,
Yeah.
absolutely. Everything after defined measure within the body of the measure, that would have probably been better built into the tabular model for reusability purposes. Not so much for caching in the case of tabular, but certainly for reusability, that would make sense. Any other questions? No? All right, well, thanks, everyone. Thank you very much. Appreciate it. Cheers.